The 100-meter sprint world record was just broken by a robot. Look at that. The difficult feat happening during the World Humanoid Robot Games in Beijing. A robot named Lightning ran the 100-meter dash in 9.39 seconds, beating the human world record of 9.58, which was set by a Jamaican sprinting great back in 2009. Okay, so here to discuss this and even more applications of the robotic technology is Heni Ben Amor, the Associate Professor of Computer Science and Engineering, Robotics, at ASU's School of Computing and Augmented Intelligence. Okay, so you know if ASU has a school that's designated to this, this is something that we need to be watching for. And this is a thing, this is something that people are getting interested in. So walk us through, I mean, we just saw video of this robot running. I mean, it is remarkable what these robots can now do.
Absolutely. Thank you so much for having me. Traditionally, we've had robots in a variety of different applications, mostly in industry. Those were bespoke robots that perform very specialized tasks, typically robots that have limited autonomy. So they do sort of the same motions again and again. They have limited capabilities to perceive the world. But now with the new generation of robots, they are now more and more capable of performing autonomous decisions, but also having a more human-like shape. We talk here about humanoid robots, robots that kind of have two arms, two hands, and for these robots to act in our environment. So these robots are coming closer to the application domains where they can help humans in their homes, in hospitals, in the security sector. But for that, they need to be able to work together with humans. They need to be able to work in domains and environments that are human environments. So traditionally, we created robots and created their specific environment. So typically, sort of a conveyor belt, a robot sitting at a conveyor belt. Nowadays, robots have to work in our homes, in hospitals, and schools. And so for that, they need to have agility and specialized routines that allow for autonomy.
So, you know, you're talking about like in a hospital. I mean, that's something that hospitals kind of, tout that they have this robotic surgery now. But you're talking about like in our home. Like, are we going to have robots that can, I don't know, cook for us, clean for us in the near future?
That is certainly kind of one of the visions, that we have robots that can perform all of these tasks and that can perform them to a level of skill that kind of matches what a human could do. But really kind of one of the goals is to also ensure kind of human wellness. So you think, for example, about, we talked earlier about robots in hospitals. In hospitals, one of the things that's really critical is, for example, repeatedly cleaning to ensure that superbacteria don't show up. And so that's something where robots can help. So it's not only about surgical robotics, but it's also kind of using robots for tasks where potentially the task could be dangerous for humans. So one of the things that we did, for example, at ASU is to think about robots that are used for landmine detection. Likewise, robots don't necessarily always have to have the full shape and form of a human. We've, for example, worked on projects where we developed synthetic prosthetic legs. So effectively, the robot is just a leg that people with amputations can use. And so that way we actually bring additional quality of life and help them regain autonomy that they may have lost because of an illness or an amputation.
It is so fascinating. So fascinating that what they can do. Heni Ben Amor with ASU. And I guess if anyone is interested in this, ASU does have a school that can help you get into this field. So thanks for joining us. It's always fascinating stuff. We're going to have you back because
thanks so much.
It's good stuff right there. All right. Thank you.